Good afternoon, class. We have discussed about telescopy, microscopy as optical instruments, but mainly we are going to talk about microscopy. As you have seen, there are two kinds of microscopy: simple microscopy and compound microscopy. We have tried to demonstrate formulas related to the microscopy when it is in normal use or when the final image is formed at infinity. So today I have organized one example of a compound microscopy. So the example says a compound microscopy consists of 10 times eyepiece and 50 times objective, 17 centimeter apart. So number A was saying determine the overall magnification. Number B says determine the focal length of each lens. Number C says determine the position of an object when image is in focus with eye relaxed. Assume for normal eye n is 25 centimeter. So let us make solution. In the problem, we have given that the magnification of eyepiece is 10 times. So it is ME is noted as magnification of eyepiece 10 times. Magnification of objective lens as noted as MO is 50 times. The separation between the two lenses noted by arrow is 17 centimeter, and the least distinction for normal person is 25 centimeter from the eye. So now solution: overall magnification. General formula, as you have proved, we got that let me say, can just say this M, this one, as a MO times ME, which means ME was 50 and MO was 10, let's say, then the times gives 500 times. Now we are focusing, our focus is to determine the overall magnification. Number A, it is done. So we can say, let me say, this is a magnification which is 500 times. So now we have asked to find also the focal length of each. Let me start by the focal length of eyepiece. So from the formula we know that the ME is equal to D over FE plus 1 or VE over FE plus 1. This formula I think you remember. We proved where it comes from. Now in our case, let me say, in our case, VE is 25 centimeter and the FE is unknown, but ME is 10. So we replace the data given in the formula. So we calculate to get that FE is 28 centimeter. FE is 28 centimeter. Now, after knowing FE as 25 as asked in part B, so we need also to find FO, but you cannot know FO if we don't know VE, UE. So using that ME equal this formula, let me say, using this formula, this one, if ME equal to VE over UE, so you calculate UE we get that UE is 2.5 centimeter from our eyepiece. Now we know that we have demonstrated that the separation, if we have the lens, let me say this is lens 1, and this is lens 2, for example, and they are separated by a distance L. Therefore, this L will be equal to VO then plus UE. Now we need to find the VO because the error was given, and from now have calculated the UE. So using this formula, we got that VO is 14.5 centimeter. VO is 14.5 centimeter. Now we can also using this formula to calculate VO. And now we press that. Remember, MO is 50, VO is 14.5, and FO you can calculate that it will be 0.284 centimeter. Now we need to calculate also VUO as asked. That in the problem they are saying, remember, in the problem they're asking us to find, the UO, VO, UE, and whatever. Therefore, after knowing FO, now we need to find the distance of object from objective lens, and we know that M is equal to V as image distance divided by object distance. I think we have proved this formula as the ratio of image distance to the object distance. Therefore, we say using the data given, M is given as 50, VO is given as 14.5. Therefore, you calculate, you get 0.29. We get 0.29 centimeter from the objective lens, as this is an object. And I hope that you have understood such a phenomenon. It is a commonly asked question in national exams and any other related to the checking the understanding of concept of compound microscopy. It is commonly asked and it is challenging question. I hope you have understood this phenomenon, and if there's any still problem confusing you with compound microscopy, please comment, provide your comment for better understanding of optics. Thanks.